Hey everyone, so today we look at problem number 253 in LeetCode. It is the meeting rooms 2 problem. It is a medium problem, as you can see. You will encounter various versions of this problem. So sometimes this problem, will come in the disguise of minimum platforms required, railway station and so on. So the idea is fairly the same idea. So let's read the description. So given an array of meeting time intervals consisting of start and end times, find the minimum number of conference rooms required. Okay, so for example, input equal to 0, 30, 5, 10, 15, and 20. So which means 0 to 30. So these are times, the start time and end times. And 0 to 30, there is a meeting. Okay, and 5 to 10 there is another meeting. So if you see 5 to 10 overlaps with 0 to 30, so which means these two cannot happen in the same room, right? So which means this should happen in one room. First meeting should happen in one room and the second meeting should happen in another room. So far we've got two conference rooms. And now if you see the third one, which is 15 comma 20. So 15 comma 20 this is greater than the second one. So by the time second one is completed, the third one, this room will be available. The second room will be available. So to this second room, we can add the third one, right? So, but still 15 comma 20 is overlapping with this one, and which means like the first meeting is still going on, right? So we have got only two rooms at the end of this one because the second has completed, and the second room we have put the third meeting. Okay, so now look at example 2. We've got 7 and 10 and 2 and 4. Okay, now if you see 2 and 2 comma 4, the start time is 2 and end time is 4. This basically starts before, right? So this will be initially allocated a room, and then we say 7 comma 10 comes, so which means by the time 2 comma 4 is ended, this room will be free. So to this room itself we can add 7 comma 10. So which means output is going to be 1. At minimum, we need only one conference rooms, right? So how can we solve this problem, right? So especially if you look at example 2, right? They have given 7 comma 10 and 2 comma 4. So when you look at this example, intuitively what you will see is the 2 comma 4 is smaller, right? So which should predate this meeting. So first what we need to do is we can sort this array, which is given intervals, right? Especially when you look at example 2, right? So it is given like this. So which means 2 comma 4 is to be brought in first, and then 7 comma 10. So there should be some sorting involved, and this sorting should be especially tailored to the start time one. Why? Because the start time is the one which determines which meeting will go first, right? So we should sort the first given intervals into on the basis of the starting times, right? This is number one step we can do. Now, what else can we do? So after we've sorted it, we've got 2 comma 4 and 7 comma 10, and then we figured out like 7, the starting time of the second interval is actually greater than the ending time of the first interval. So which means to the same meeting room we can put this one, right? So basically after sorting we are basically manipulating the minimum room logic on the basis of the start time of the current meeting with the previous meeting's end time, right? So now look at example 0, 30, 5, 10 and 15, 15, 20. So given this example, what will you do? Right? So let's say we've taken this example. So and if you observe this method is, this example already has this sort time sorted, right? So the starting time is 0 and starting time is 5 and starting time is 15. So all these are sorted as per their starting times. Now let's say we have put 0 comma 30, which is the first meeting, right, in one particular conference room. Now we see 5 comma 10. 5 is the starting time of the current meeting, and this is not greater than or equal to 30, which means we need to add this to another meeting room, right? Basically we should allocate another meeting room. Now we see 15 comma 20 is the other remaining input, and 15 comma 20 is something which we are comparing with the ending time of 10, right? So basically we are not comparing with the ending time of 30, we are comparing with ending time of 10, right? So which means we need a way to basically get the minimum of the current meeting's end time, right? So which means and then once you have it, then we basically check whether its ending time, if it is if the starting time of the current meeting, if it is greater than or equal to the ending time of this, then basically we can add this 15 comma 20 to this meeting room, so that we will just have only 2 meeting rooms, right? So sorting these intervals based on starting times is straightforward. Now how do we get 5 comma 10? 5 comma 10 is the one, because intuitively when you look at this example, you're able to make out like 5 comma 10 will finish fast. Now we need to identify that 5 comma 10 is the meeting which will end before 15 comma 20, right? So for that we need a data structure. And what data structure can you think of? Basically it is the priority queue. So now if you have a priority queue, and let's say we have put 0 comma 30 first, right? Only 0 comma 30 is there. Now 5 comma 10 comes, and then we compare the starting time with the starting time of this. If it is greater than or equal to 30, no, it's not. So which means we can put 5 comma 10 also, right? And let's say so if this is a min priority queue based upon the ending time, right? So 10 will be at the root, and 0 comma 30 will be at its, it will be at it will be a child, right? And now we can compare 15. Now 15 if you compare with 10, 10 is obviously less, so which means to this can be removed, and you can add 15 comma 20, right? And so 15 comma 20 will be getting added, and this will be at the root. So basically we need to have a priority queue minimum heap, right, which is an implementation of the min heap structure, and that min heap property should be dictated by the ending times. Okay, so first what we do, intuitively we sort this based upon the starting times. The logic is first sort this based upon the starting time. So we've got the same output here because this is already given in the sorting form. Now what we do, we add the first meeting. Anyhow, we've got the first meeting. The first meeting has to be added somehow to the project. So we'll add the ending time of the first meeting to the priority queue. Now we see the start time of this is actually within the limits. It's not greater than or equal to. So which means we need to add, we will be adding the ending time of this particular interval to the priority queue. So now we've got 2 entries in the priority queue, and by the min heap property 10 and 30 will get rearranged, and you will be having at root you will have 10 and then you will have 30, right? Now we will compare the starting time of this with whatever is at the top, right? So 10, it is lesser than or equal to 15, which means this can be removed, and we will be putting in 20, right? And the structure remains the same because 20 is less than 30, and so this will be so. By the end of the day, whatever the size of the priority queue that remains, that will be the minimum number of rooms that are required. Now let's walk through the same example for example 2. Let's walk through the logic for this example 2. So now you've got this example. So now if you sort it based upon the starting times, you will have 2 comma 4, and then you will have 7 comma 10, right? And now let's add the first meeting's ending time, which is 4, to the priority queue. Now we see 7 it is greater than 4, right? So which means this can be removed, and so you will basically add 1. So at the end of the day you will just have 1 meeting, right? The size of the priority is 1, and that will be the minimum number of rows at 1. I hope the logic was clear. So let's quickly code this problem. Now if intervals, so we'll just do the corner cases. If intervals equal to null or intervals dot length, if this is equal to 0, then minimum number of rooms meeting rooms will be 0 because there are no meetings as well. So now we said we will sort it based upon the starting times, right? So arrays.sort and intervals, right? So we need to write a new comparator based upon the starting times. I will write this, so compare. I will take A and B. It will take one dimensional because if you see, each of these is a two-dimensional array, right? Each of these is a two-dimensional array, and we need to sort them based upon their start times. So which means here the 0, the element is the start time, right? So which means return A of 0 minus B of 0. So we have sorted this based upon their starting times, right? Yeah. So now we have sorted it. Let's have a priority queue. Priority queue, by default, priority queue implementation in Java has an heap, so we can just initialize the priority queue. So we'll say pq equal to new priority queue of teacher. Okay. Now to this, this is priority queue. Okay. So to this we will be adding ending time of the first interval, so which is nothing but intervals of 0 and 1, right? Now for we'll iterate over the rest of the intervals. So this we have added one interval already, so we need to start from 1, and index is less than intervals dot length and index plus plus. Now we will compare if intervals of index is if the starting time of this it is greater than or equal to whatever is there in the priority queue. So we have put in the ending time of the first interval here, and if this is greater than or equal to, right, then which means we can remove the meeting here, right? So you saw 2, 4 was there. 2, 4 was there in the priority queue. We added there, and we saw that 7 is actually greater than 2, which means 2, 4 can be removed, right? So that condition. So we will remove pq.hold, right? And we need to add pq.add of this particular interval. So we have removed that, and we will add intervals of index and 1. So the ending time of this we will be adding. Okay, and this will proceed, and then finally we will return pq.size. This will return you the minimum number of meeting rooms were required. So if you sort this, right, so for the first example, this is already in sorted form, and pq.add of intervals of 0, 1, which means the ending time of 0th interval we're adding. So here actually 30 will be there in the priority queue, and then index equal to 1. From index equal to 1 we will start this, and we check whether intervals of index of 0, which is 5, this is the starting value, and if this is greater than or equal to whatever is there at pq stop, which is 35, is never greater than or equal to, basically we're checking is 5 greater than or equal to 30. Now it's not the key, so we cannot pull it, right? So this basically is overlapping, right, in that condition. So which means we will be adding 5, 10 also to the priority queue. So 30 and then 10. So basically this will get rearranged, right, by the priority queue ordering, because this is a minimum queue, so minimum heap, sorry. And so you will have 10, 30. Right, and then index is equal to 2, so which means 15 and 20. We will again compare its starting time with that of the pq.peak. So pq.peak is what? 10, and 15 is greater than or equal to 10, which means definitely you can remove whatever is there at the top, right, and you can put in 15 and, sorry, 20, right, ending time, and 20, 30, right, and no reordering because it is already in its place. So finally, we have exhausted this loop. So 20, 13 will remain in the PQ, and PQ room size will be the minimum number of meeting rooms required, which is nothing but size 2. Okay. So now if you see the time complexity, what will be the time complexity? We are sorting the array, right? Basically, so this will be O of n log n, and then we are manipulating all these things by adding to the priority. So addition and priority queue will be log k, and we are basically iterating over the intervals, which is n into log k, but then n log n is a bigger complexity. So the time complexity will be O of n log n. Right. What about the space complexity? So we are having a priority queue to store all these intervals, right? The ending times. So at the max, it is going to be O of n, because the ending times of those intervals are what we are basically adding in the priority queue. So the space complexity is going to be O of n, and the time complexity is dictated by the sorting. Okay, let's run this code. It's accepted, it's submitted, and it's a successful submission. I hope it was clear. Bye, guys.